Solve triangle ABC if side A has a length of 30, B has a length of 20, and angle A equals 50 degrees. And we know round this to the nearest tenth. All right, so the first thing we should do is draw out this triangle so that we know which type of triangle we have and also which method we're going to use to solve it, right? So we know that angle A is 50 degrees. Okay, so that's actually the only angle that we know, right? So let's check it out. Side A is 30, right? So that's going to be the side opposite angle A, so that has a length of 30. And side B is 20, right? So that'll be this side, the side opposite angle B. So what type of triangle is this? Well, we have two sides, okay? But in this case, the angle is not in between the two known sides, right? So this is called an SSA triangle, okay? So actually, the order of the letters is actually very important, right? So SSA means two sides and an angle not in between, okay? So if we did know the angle in between, that would be called an SAS triangle, which would be, we would use a totally different method in order to solve this, okay? So with an SSA triangle, we have to use the law of sines, but the key point here is that we have to be careful because it's possible that there's no solution, right? That there is no triangle that fits these measurements. But on the other hand, it's possible that there's two such triangles, okay? So what do we mean by that? Well, let's work it out, right? So first thing we should do is set up the law of sines based on the given values, right? Okay, so we know that the sine of A divided by its opposite side is equal to the sine of B divided by its opposite side is equal to the sine of C divided by its opposite side. So let's fill in what we know, okay? We know the sine of 50 degrees over its opposite side, in this case 30, equals the sine of B over 20 equals the sine of C over its opposite side. Okay. So you notice that in this case, we have three ratios, but this ratio, none of the values are known, okay? So we're going to have to solve for this last, right? But we can do this first, right? We can solve for angle B here, okay? And then once we know angle B, we should be able to determine what angle C is because we know the sum of the angles in a triangle is 180. And then we should be able to use the law of sines one more time to solve for side C. Okay, so let's set it up, right? We'll use the first two ratios here. So we got the sine of 50 over 30 is equal to the sine of B over 20. Okay, so we can set up, well, using this proportion, we can cross multiply, right? So 30 times the sine of B equals 20 times the sine of 50, and then we'll just divide out to 30, right? So the sine of B is going to equal 20 times the sine of 50 all over 30. Now remember, in this case, we're solving for the value of B itself, right? So B, okay, in this case, B is going to equal the sine inverse of all of this guy right here, right? So 20 times the sine of 50 all over 30. Okay, make sure you use, when you're using your calculators, right, you want to calculate this first, okay? So calculate whatever, 20 times the sine of 50, right? And then divide that by 30, so you get your number here, right? And then you'll take the sine inverse. All right, so when we calculate this part out, right, so I'm just going to calculate this part. Okay, so using your calculators, 20 times the sine of 50, all that divided by 30. Okay, so we actually get, let me write this out first, about 0.51069 right? So you don't need to necessarily round this, right? You can use your calculators and just figure out the sine inverse right away. Okay. Now you got to be careful with this, right? Once you calculate this number, right, B, angle B, your calculator is going to tell you that's 30.7, okay, degrees. Okay? But here's the thing, right? Remember, sine is positive in the first and the second quadrant. So there are actually two values where sine could equal 0.51, right? So the other one is we'd have to subtract this from 180. So it's possible that B could be 30.7 degrees, or, right, B is going to be 180 minus this. Remember, we're just rounding this guy, okay? So 149.3 degrees, okay? So for example, if you get your calculator and hit sine of 30.7, we should get something close to this number here. And similarly, if you hit sine of 149.3, right, we should get something close to this number. So there are two possibilities for the value of angle B, but, right, check this one out, right? 149.3, that's not possible, okay, in terms of this triangle, because we already know that angle A is 50 degrees, right? And obviously, if you add 50 to 149.3, we're going to be bigger than 180 degrees, okay? So actually, this value will not work, which means then that B does indeed have to equal 30.7 degrees, okay? All right, so now that we know the value of angle B, right, now we should actually be able to figure out the value of angle C, right? Remember, the sum of the angles in a triangle is 180. So now that we know these two, right, we should be able to get C. So C is going to be 180 minus these two guys. It's going to be 99.3 degrees. Okay? And now we can use the law of sines once again to figure out side C. Okay, now, remember, this is called an oblique triangle. It's not a right triangle. Okay, so we cannot use the Pythagorean theorem here. You have to use the law of sines. So the sine of 50 divided by 30 equals the sine of 99.3 divided by C. Okay, so once we cross multiply this, we get C times the sine of 50 equals 30 times the sine of 99.3. Okay. Sorry, running out of space there, right? So basically, C will equal 30 times the sine of 99.3, and all of that divided by the sine of 50. Okay. When you're using your calculators, make sure you're careful as you input these in. Make sure you know how to use your calculators, how to input these trig functions. Okay. So sometimes you have to hit the degree and then sine, or some of the calculators you have to put sine and then the degree. Okay. Now either way, right, you should get C equaling 38.6 in this case. Okay. So we've successfully solved a triangle, right? We've determined all the values, right? All three angles and all three sides.